Hello everyone, welcome to this class. Today we are going to start very new topics, which is the neural network or the deep learning. Okay, before starting this topic, guys, let's understand what is deep learning and where this deep learning exists in the AI. So in the first class, I already explained this Venn diagram where AI is the parent of all the technology, where ML is the subtopic. Same as ML, DL is the subtopic, means deep learning. So what is the difference between ML and DL? Okay, let's understand that. ML and DL has same approach for the making the prediction algorithm, but here we have six sort of algorithms such as linear regression or logistic regression, suppose KNN, SVM. This is some more popular model which is include inside the machine learning. But deep learning is also a machine learning. It is not a new topic, but deep learning is used neural network to making the model. They are only using the neural network every time. If you are using this linear regression, have different sort of formula. In the logistic regression, they have some different sort of formula. In a linear regression, the formula is y is equal to wx plus b, and in the logistic regression, the formula is this. In the KNN, they use the distance formula, and SVM they are using vector. So they have different type of approach to be solving a problem. But in the case of neural network, they have a single way, means using a neural network, make the model, and you can solve any problem by using the neural network. Even neural network is capable to solve all the problem of this algorithm can the possible. But this algorithm is not capable to solve every problem which is solved by the neural network. So here neural network win every war. Okay. So in this classroom we are going to discuss these things and understand why and how can use the neural network to making a model. Okay. So I guess machine learning and deep learning is not a new topic for you, I guess, because you already seen this type of thing in most of the time. Even you see some poster where in the poster you have seen this type of a structure. Okay, I guess you have already seen this type of a structure somewhere in the internet, or maybe in the Facebook post, or maybe in the Instagram post, and somewhere. Okay, you already see this post, see this type of post. Okay, so this is nothing, guys. This is your neural network. Neural network means neuron. This is called the neuron, and this is when you use multiple neuron, this is called the neuron network. Okay, so we are in this classroom, we are discuss every point of this network. This, what is this, what is the meaning of this, what is the meaning of this, what is the meaning of this, and so on. So let's start one by one. So how the neural network solve the problem? So in the first day of class of machine learning, I explained the machine learning has two types. One is supervised, okay, and one is unsupervised, okay. In the supervised, again there are two types. This is called the regression, and second one is classification, okay. And there is unsupervised. We are not discussing this part because unsupervised has the data is not a label, okay. So we are not discussing this part in this time. So again the same as the deep learning has two types, because deep learning is not deep learning is a part of machine learning. Unsupervised, supervised. Deep learning also have two types of supervised, regression and classification. So for suppose if you were using the regression, means the regression means output is could be anything like 9.1, 3.2, 1.5 and so on. But in the case of classification, output is fixed, either 0, 1, yes, no, is alive, dead, fair, dark, pass, fail. So you know this type of output is fixed. So you are under the classification. Okay. So suppose this type of model can be solved with the classification model, like in the machine learning, like logistic regression, KNN, SVM. But in the case of regression, suppose their output is like 9, 0.9, 2.8, or something, like any output is possible. So here you see this type of regression, you can solve with the linear regression, or maybe some other, like SVM also is capable to solve the linear regression. So here you see this type of model. But in the case of deep learning, this all the approach is the solved by the neural network. So how the one neural network can solve two problems? So let's understand that. Okay, let's understand that. So mostly we are cover mostly the classification, because we are dealing with most of the time classification problem. So let's understand that. So suppose what's happening, how the neural network looks like. The neural network looks like this. So what is the meaning of this dot? What is the meaning of this dot? What is the meaning of this connection? Okay, let's understand that. So basically, this is a transformation of data. Okay, so suppose you have a, machine learning can be solved with this graph. Here input is like a feature, output is like this. By using this input output, you can predict your equation y is equal to function of x, and this is your model. So every time you are using this approach, the same means here if you see, focus only one network. So the network looks like this. Okay, here this input is called x0 or x1, and this is your y. Okay, and you can divide this layer in two parts. First part is called the hypothesis, and second part is called activation. Okay, so here hypothesis is nothing. Hypothesis is a equation between your input and a random value is called weight. Okay, so it looks like x. Okay, and also because we are adding a single number called bias, so we can adding this. So this is your hypothesis. This is your hypothesis. And activation is a function who who will who will control the output. Who will control the output. So activation is a function of hypothesis. Activation is a function of hypothesis. Suppose you are going to create a neural network. A neural network is a network which are using for classification, and classification means maybe their fixed output. Suppose 0 or 1 is the output is possible. So using this classification, so how we can we solve this problem with the neural network? Means you come with an input, your model is a neural network model, you come with input output, you come with neural network, and you will get a equation which is a function of x. So how we do that? So we again means this is your input, this is a random number which is called the bias, and we add w and something like that, and we get the hypothesis. Hypothesis generally looks like a linear equation, and you pass the hypothesis in some function is called the activation function. So the very popular activation function are we have available. First activation function is called sigmoid, which is already seen. in my previous classes of the logistic regression. Second activation function is ReLU. Third function is 10H or 10 something like that. This is some like popular activation function. This is enough for controlling the output. So now already you see the sigmoid function is nothing. If you see the graph of sigmoid function, the graph is looks like this. Okay, here highest value is 1. This is the activation function, and the activation function is formula y is equal to z if this is a function of z. Same as ReLU function and nothing. ReLU function graph is looks like this. Is reduce the negative value and only focus on the positive value. So here is a function in nothing. X is equal to x if x greater than equal to 0 or 0 if x less than equal to 0. Okay. 10 function I don't know right now. I'm not remember yet, so I will discuss this thing later because I didn't use 10 in most of the cases. Okay, so you see this 2 function or 3 function is there, sigmoid and ReLU, and we are going to use this function as an activation function. Okay, so now let's understand with a simple example. Okay, suppose you are going to create a neural network and you have 2 tasks. One neural network is going for classification and one network is going for the regression. So how we can solve these 2 problems with a neural network? So this part is the regression. This part is like classification. Now see, neural network looks like you pass the input with a network and you get the output. Okay. Same as neural network, nothing. Neural network pass the input with a network and get the output. Clear. So now here output is like a fixed value like 0.9, 89, 8.9 or 98, could be anything in a regression. And in the activation, in the classification output will be 0 or 1 maybe. So let's see how can we solve that. Now first you come with the input make hypothesis. The hypothesis is nothing. Hypothesis is a between of x naught, w naught, x1, w1, x2, w2, and some adding a bias. So you can also consider this as or maybe x w transpose plus b. It is similar to this, which already explained in my previous classes. So this is the function. If you're going in the regression, don't need to pass this hypothesis into any activation function where y is equal to directly h in the case of regression. Now in the case of classification, same x naught, w naught, x2, w2, x3, w3 and b, and it is a nothing, it is your x w transpose plus b, and you know you are using the classification, don't worry, you will pass hypothesis in some equation. Here g is your activation function, maybe sigmoid. Suppose you are going to use as a classification, sigmoid is enough for making this sigmoid. Okay, you can solve this. But the problem is, you told me, sir, looks like a linear regression. It looks like a logistic regression. Sir, why we are learning neural network? Okay, the good thing is, yes, looks like a looks like a linear regression. It looks like a logistic regression. But we should stop the problem. We don't need to go from this, because if we do not get a very good value or good accuracy value after solving this problem, then this model is not good for that data set. But suppose, okay, now if you're checking this accuracy in the case of classification after getting this, so maybe your accuracy will be 70%, not 90%. So there are two options. Either you will shift to different model, suppose like SVM or some model. But in the case of neural network, the good thing is you can solve the same problem with the neural network again. But this time you will increase the neuron. Right now you are using only one neuron and you get this equation. But I am going to increase the neuron. So this neuron is called single layer neural network. This neuron is called single neuron neural network. But now if you didn't get the value accuracy value not more than 90%, we increase the neural network, something like that. And now next time I'm going to use this network. Okay, again you can draw this. Now see, so here there are multiple hypotheses. This is hypothesis 1, this is hypothesis 2. Now hypothesis 1 is what is get? Hypothesis 1 is looks like x naught, w naught, x1, w1, x2, w2 and some bias. X2 is looks like maybe x naught, w3, x naught, x1, w4, x2, w5 and some bias and so on. Here we have passed after the activation, you will get A1 and this is A2. Now A1 is some function is passing through the hypothesis. Okay, suppose you are using any function like ReLU or sigmoid, but generally if your network of your neural network is not the network, if this neuron is not the end neuron, so I recommend to use ReLU. ReLU give the better optimization over the sigmoid if you are using ReLU in the middle layer. So suppose I am going to pass ReLU and you will get some value. Again you pass A2 with some network and you lose. So now this A1, A2 behaves as an input for this neuron. Now this is you will get H3. And H3 is like A1, W6, A2, W7 plus some B, and this is your hypothesis. Again you will pass to activation because you are solving for the classification. Now this time suppose I am going to use activation as a sigmoid, and you pass this H3 here and you will get the value between 0 to 1. So now what's the benefit? Because you increasing the number of parameter, means that's why it is very high chances your equation could be the more complex equation, and it is better to solve very high level of problem which is not solved by the algorithm. Okay, so that's why we are going to increase the network, and maybe it is very high chances your model will get the accuracy more than 95% or maybe the 90% after increasing the number of layer. And I will show you and prove this that by increasing the layer of network you will get better answer than single neural network. But guys, for that you have to understand that how we create a neural network. So this is a theoretical part. Guys, if you have any question, any query, that you are facing to understand, please let me know. I'll try to solve you, because I am going to implement this theoretical thing by the code using the TensorFlow. If you are facing any problem, please let me know. Any problem? Hello, hello, yes. If you are facing any problem, please let me know. No problem, Himanshu. At least say, okay, good. So now open the Colab, and guys, if all the students who join late, don't worry. I will try to explain this part. Just 1 second. And guys, I'm showing this. I'm going to implement this all the thing, all the approach in the using the TensorFlow in the Colab. So let me open my Google and open the Colab. Okay, and first I'm going to open a new notebook, and I'm going to part intro to. Okay, see, first we need a data set. So I'm not taking make you more confused. So I'm using the same data set which already in my use my previous classes. So a change you made not be saved. Leave. Oh, sorry, we should open the new notebook. Anyway, I need this. Yes, need this. Just 1 second. I need this. This. And I need this line. Also, I need this line. Okay. I need Control C. Okay. Why this not showing into deep time? Okay. Control. Okay. Okay, now see. So let me run it. Okay. So plt dot plot uh, data dot labels cmap is equal to my cap my cmap. Okay, the data set look like this. So now let's create a like just 1 second. Okay, so now let's go with the one by one. So I will do in this classroom, I will do two approach. In the first approach, I am going to create a single neural network, and I will train the model. And the next time I will increase the layer of the network, and again see what is the benefit after the increasing the layer. The first approach is using this single. Okay, and the second approach I will use increase the layer of the network, and we see that how we'll get the better answer. Oh, sorry. So now because we are using the TensorFlow, and TensorFlow very easy to understand. Same as sklearn, we are importing the TensorFlow. Okay, and there are two libraries actually. The TensorFlow and second library is called Keras. We can use both, but Keras is very created for Keras is generally used for Keras is generally good for making the neural network for high level API, because most of the time you are seeing the next Keras. So I am importing TensorFlow not directly, but I am importing TensorFlow from Keras. TensorFlow. Now I am using one more library. Don't worry guys, I will explain everything. So from Keras import layers. Okay, I will explain everything. Okay. So what I'm going to create? So I'm going to create this. Okay, this is all the input. This is like x0, x1, x2, and this is your y. So here you see it is your input. This is called the input layer, and this is called the output layer. If you are using more layer, here you get that, and this is called hidden layer. But good thing is we are using single layer, so we don't have any hidden layer. So first we are starting with the single layer. Okay, like this. So this layer is a function which help us to create the neural network. Let me run it. Okay, now I am going to create a variable one layer model. Guys, this is a simple model, same as sklearn. When I creating sklearn import logistic regression, so directly you create a model name and we assign to the sklearn model, the same as that. But here I am going to use neural network, so I am using TensorFlow to make the neural network. So first, and I'm not telling only the TensorFlow is a one single library which help us to creating a neural network. So lots of libraries are there, such as not lots of, but popular library are the PyTorch or the TensorFlow. Apart from other things, but they are not enough to make a good neural network model. So I'm going to use called Keras. Okay, one for function I'm going to use. It's called sequential. Just one second. Just one second. If you run this, sequential. Sorry, just one second. Okay. So how we do that? We consider this. Sorry. Okay. We consider every layer can be stored in an array. Okay. This is a layer 1. This is a layer 2, and this is a layer 3. Suppose like that. And every layer is also contain the information of the number of neuron. This contain 3 neuron, this contain 2 neuron, this contain 1 neuron. So if you see how the neural network looks like, so this is looks like 3, 2 and 1. So this is the neural network, and this array can be created with the sequential function, and this is the can be created with the layers, and we put different name for this. Here we are using dense, and I will explain later. So now first I am going to use sequential. The sequential is need a parameter which is an array. An array contain the layer, because we are going to create one in one layer. So I am going to use layer, and first layer is called dense. Okay, the layer with the dense function. So now dense function needs some argument. First argument is called unit, and how many unit you are going to add? I am going to use single unit. किधर गया? Single unit, because this is the only the one neuron I'm going to use. Input layer not considered as a layer or neuron. This is not a neuron. Only the this is a neuron. Input layer is not containing any neuron. Okay. Unit 1. Second, how many input you are going to pass? So input shape is 2. Okay, because this is a feature, this data set contain only two input, x and y, or x1 and x2. So that's why I'm going to use input shape is equal to 2. Clear? This is the way that you have to create the layer. Now run it. Now next, because after the creating a neural network, after the creating a model, suppose you follow this graph. This graph is like input, output, create the function of x, and this is your model. So this model is your one layer model. Okay, that's perfect. And now we are going to use this model. Suppose model is here just like that, ax plus b, something like that. So you know you need to find this value of a and b. In the case of neural network, this y is like activation function of hypothesis, and hypothesis is nothing. Hypothesis is like a, or like x naught, w naught, x1, w1, and b, because there are two inputs only. So y is like activation of x, w transpose, and b, or maybe the w I'm going to use. So means at the end you need to find the value of w and b, because activation is just a function. So same as you are using the gradient descent algorithm, something like that. You choose some random value of w and b, and this is your loss function, loss value, and you are starting with the updating the value. Okay, the same thing also done in the TensorFlow. Okay, w and b, but last time you have fixed the learning rate like 0.5. Also you decided used the for like changing the getting the loss function, you are using this y minus y prediction ka whole square. Okay, this is called the mean square error. So this type of thing is controlled by the TensorFlow, and you have to mention that. So suppose you are this like this type of thing like the value of 0.5 and whatever, this all the thing is controlled by the optimizer. And TensorFlow containing the optimizer, multiple optimizer, but popular optimizer is like Adam. It is the same as the gradient descent, and it is called the Scottic gradient descent. Scottic gradient descent. And there one argument also containing the optimizer is called loss. Which loss we are going to use? Suppose you are using MSE, mean square error, you have to pass that. Okay. So how we can do in the TensorFlow? Simple. First, you need to be add one layer called the model, one layer model, and you have to compile with your attribute. Compile with optimizer, and optimizer you do what? Adam. And this is nothing, this is you can consider as a gradient descent. Now second is loss. There are multiple loss is possible, but I already see the most of the time in mean square error, so that's why I'm using the MS. Okay, mean square error. So now the same thing is done. Now we have to run it. So now your model is ready. The next you need to train, but you know for before the training we need to split the data set in two parts in X train. Okay, we need to be import this. Sorry, not X5. It's called like data labels, and I'm so passing a random zero whatever you can pass. Okay, now let's run it. Train test. Just one second. Oh, I didn't run this now. Now see the shape, print extrinsic, print vitrinsic. Sorry, extrinsic. And you see X should be in uppercase. And you see that 750 rows for the training and 250 rows for the testing. So now let's start the training. So one layer model fit again is a function and you pass the data set. Okay, and again because in the training you are updating the W and B with some set in some number, like starting with this one time you are starting with this value and again next time you're taking a step 1, a step 2 and a step 3, and you know this step is called epochs. The third argument you pass the epochs, and epochs I'm making as 1000 EPOCH or maybe the 500, whatever you have to add. 500. Oh, sorry. Just 1 second, everyone. Okay, now you see, and now this is the training. So now we are going to store this training in one variable. It's called history. Okay, because this is the history of one neural network, so I'm going to use history 1. Okay, history 1. So now we are going to start the training, and don't worry, we don't use the TQDM because TensorFlow already inbuilt the TQDM feature, and when you run this it will start as some progress and you see the loss, and in this pass you see that this is the loss value, which is decreasing some in after the set of number of time, and after the 500 epoch, see what is the loss. Like right now the loss is 0.25 and so on. Guys, you see after the okay, and you see after the epoch you see the loss function is 0.228 and it is starting, and you know in the first case the loss is in some big number. So now let's see plot this diagram in the loss function diagram and see, suppose I'm going to pass, okay, this history value. So for seeing this is history, I'm going to one elaborate only for that, nothing else. Pandas. This is a data frame library. Generally, this library used for the data analytics. So suppose I'm going to add one layer loss data. Suppose I'm going to pass a variable, and this variable is getting from pd.dataframe. Guys, this is a one time. If you're not understanding like pandas, don't worry about it. This is not like mandatory for this class. Data frame, and you pass history 1 dot history. Okay, so this history 1 dot history will return the information of the loss, and it is doing that. And if you using one, let me run it first. Okay, let's see what is containing in this. So I'm taking only 5 top value, 5 value or 5 value. So let's see what is the containing this value. This is the information of the loss. Okay, and if you now I'm going to be draw this graph. So it is easy, either you can use the matplotlib or you can directly use this one layer loss data dot, sorry, uh, loss, and directly pass plot. Don't need to use the matplotlib to draw this. And you see the graph, that how the graph is decreasing of the loss. Means one layer it's better, one layer is also it is a better, and it is decreasing, it is good. But see what is the accuracy, guys. What is the accuracy? What is the accuracy? So now I'm going to use, just one second, open new notebook, just one second. I need the code. I don't want to write the code again and again, which is already, yes. Okay, you need this code. Okay, now see, only model should be changed. One layer, one layer. Let me see, one layer or what the model name is. Okay, make sure this is the model. So suppose I will predict the model with this, and we converting the value which is greater than 0.5, it's convert to this, and this. Okay, this is your 250 values, and now I'm going to check the accuracy. So accuracy is like we have to import from sklearn. I guess accuracy function is also ready. So this is your accuracy. But the problem is we have to be import this accuracy model before running this accuracy function. So let me check this. Where is the accuracy? Run this accuracy function, and this is white test. This is white preview. Okay, now see. And accuracy is 66%. It is good, but not best. Means your one layer network is getting the accuracy of 0.6. Okay, one layer network is returning the accuracy is 0.6. It is good, but not the best. So now I am using the copy this code on the same data set. Now I'm going to use copy this code and see what is happening. I'm using this code. Everything is same. I'm not going to change anything, only increasing the layer, and I'm going to use multi-layer, and see after the multi-layer what is happening, guys. So in this case, let me add sorry, multi-layer. Okay, see, after the increasing the multi-layer neural network, let's see what is happening. Right now in the multi-layer, what I'm going to do, I'm going to say that your output is the input shape is good, and I'm using this because let's see what I'm going to do. I'm going to create this network. Two input, okay, one bias. This all this is going with the another two layer, okay, and then at the end you'll get y, okay. So this is a one activation function. Here I am going to use ReLU. Here I am going to use ReLU. Here I am going to use sigmoid. Okay. So this network I am going to do in my by using the TensorFlow. So everything is same. Everything is same. Let me Okay, everything is same. So after the single layer which come with the two input, we need to be add a ReLU function as activation. So two way, either activation function add in the next line, or you can directly add the activation like this. So activation ReLU. Okay. Now second, this is a layer dense, and also this layer, this after this input, just 1 second. Okay, means after getting this two input or one bias, it will generate two unit, not one unit. Okay, it will generate two unit. So you have to pass unit 2, and for that case this will generate one unit. So now I am going to add dense unit 1, or maybe add one more unit 2, and activation function again. Okay, so basically this network is looks like this. Between two neuron and it is getting like this. This is your input and this is your output. This is a neuron, this is a neuron. So that's why I'm using 2 and 2 ReLU. Okay, now only for the first layer we have to pass the input shape, because neural network don't know what the input shape is. But after getting the first layer, you know already mentioned the unit to 2. So you, this for this activation function, this layer, he know the unit is input is 2, so don't need to be mentioned that. Now here unit is, sorry, 1, and here I'm going to use activation sigmoid. Okay, nothing else. If everything is right, so I'm going to run it. Okay, there's one comma I'm forgetting this point. uh, why? Okay, why this error is coming? Hello, hello.
हेलो अस्सलाम वालेकुम।
हाँ सदा, आ जाओ.
ठीक है।
Okay, here you see, let me check why this error is coming. Let's see. You need, oh sorry, its spelling is wrong. I guess everything is right. Okay, now so now we need to compile same model with the same. Okay, and I'm going to use loss is equal to MSE. Now everything is set. Sorry. Epoch again I'm going to use 500, not increasing the epoch. And because I want to see the graph and all, so I don't want to see the graph and all because I already see the loss function in my data. So let's start this training. There's something issue. Oh, sorry. You need to compile the model. Uh, just 1 second. This is called the optimizer. Optimizer. Okay, now see. Now epoch has been started, and you see the loss function is like 0.4 still here, and you see how the loss function is so small, 0.03. Last time your minimum loss function is 0.02, but in this case after only 300 epochs your loss function is returning like this. 0.02, 0.01, 0.02 and 0.01. This type of loss function you are saying 0.02, and the last time you see the suppose after the end of the epoch you get the loss is 0.02, but in this time your loss function after the 500 epoch is around just 0.2 only. So you see by in this loss is decreasing by the 98%, and this time the 0.02. So now let's see the accuracy. So let me copy this code and okay, and if you see the accuracy, oh, just 1 second. Sorry. It is the multi-rate one. Okay. See, your accuracy increases by the 97%. Okay, just increasing the layer of the network, you're getting the 97% accuracy, and it's very good. 97% very good for the deep learning approach. So now tell me, guys, are you understanding the deep learning? If you're not, I will repeat it again. Okay. Basically, this function is called the first of all is called there's some activation function which is help us to make computation better. So very popular activation function is sigmoid. In early days when the neural network is like very popular, so most of the time people are using activation function sigmoid always, but they are not giving the better result every time. In the if you're using sigmoid neuron sigmoid function in the middle of the layer, after the certain amount of time you'll get different type of activation function. The second one is ReLU. ReLU is like, sigmoid function is what? If you're passing any value in the sigmoid function, they are returning value between like 0 to 1, 0 to 1. But in the ReLU approach is like if you're passing any value in the sigmoid ReLU function, it convert to x if only if x is greater than 0, otherwise it's decrease to 0. Means ReLU function remove the negative values. Okay, and when the people are starting to using ReLU in the layer of the neural network, and they are see like their output is very good, and their accuracy increases. So activate ReLU is nothing. ReLU is simple activation function where this function returning this. You passing any value in the activation function of ReLU, they are returning that number if the number is greater than 0. Otherwise, they are decreasing to, they are set to 0. Okay, nothing. This is only the ReLU. Sigmoid is nothing. Sigmoid you passing any value is converted between 0 to 1, and sigmoid function is what? Sigmoid function is this. Clear? Himanshu? Any more query? And you also see that how the accuracy increases after the layer of increase. But in the it doesn't mean that you can increase the layer like 1000 number of times, 10,000 number of times. You have to understand how much epoch will be better for that data set, or how much a number of layer is good for that data set. So it is like very challenging for the data scientist or for the machine learning engineer to understand how many layer is enough. So this is come after the practice or after the certain number of hidden trial method. There is no shortcut at all. Any more query, guys? If you have any query, if you're not understanding any line of code, please let me know. Okay, let me share the code because this code is very important. Please go and understand the layer because in the next class I'm going to start the other part like using the real project with the this data set with by using the neural network or maybe the TensorFlow, and we creating a different type of code like a digit recognition by using the TensorFlow. Okay, and I'm going to implement with in my upcoming class. Okay, but if this approach you can understand that code only when you are understanding this notebook. And also we are going to be next class I am going to explain the vectorization method. Sometimes we have to convert the output to a different format for better result, so I will dealing with that in my next class. Any more query, guys? Yes or no? So let me share the code. Yes, definitely this course will be finished by 8th February, I guess, because only 3 or 4 classes are remaining. Okay, if you are like urgent, I will take the class on the Sunday too. Okay, there is no problem at all. Okay, Himanshu, don't worry. The other classes is going to little bit so faster because the project we are going to share the code with you. You can see the code, understand the code. Okay, so maybe in my in my next week every class is there is a continuous class. There is no off on your classes. Oh, sorry, guys. If you don't understand any point in this code lab, please comment on this Google Classroom. I'll try to help you in the next class. Okay. So, okay, guys, go and practice this code. And if you understand, if you are stuck anywhere, please let me know.